Well, this is our first of two stops for plant pathology. We have two persons that will be making some comments at each of the stops. The first is Sam Markell. Sam is our extension plant pathologist who specializes in broadleaf crops. So Sam Markell is originally from Minnesota. All right. He got his master's from NDSU in plant path. He went on to the University of Arkansas and got his PhD. And then he's been in the position since 2007. So we're very pleased that Sam was able to join us today. He's going to kick off the discussion on plant pathology, and then he'll be followed by Dr. Michael Wunsch. Michael's originally from Montana. He got his PhD from Cornell in plant path. Michael's been with us this is his fourth season. He has an extremely aggressive plant path research program, and so I think you'll really enjoy the discussion by both these gentlemen as they talk about diseases. So only they can get especially excited about diseases.
So I am originally from Minnesota, but I haven't lived there for 18 years. And I'm living in North Dakota by choice. No offense, Greg. So I was asked to give a perspective on some of the diseases we're seeing in the state, the big picture, and then come back to Carrington. And there's really three fungal diseases that I think about every spring. Kind of the big three that I worry about, and I wonder which one's going to hit. And they are different environmentally induced. So the different environments will move these diseases forward. So I want to talk about the weather a little bit. So if you're in Langdon right now, and the high temperature is a balmy 72, and you've had inch after inch after inch of rain, what disease should you be worried about in that area? Come on, you guys know this. Remember 2009 when all the dry beans melted down? It's white mold. Okay, so white mold is a concern up there. I've had dozens of phone calls in the last week from that area because it's been so cool and so wet. Okay, that's not our problem right here. You guys are relatively dry and you're definitely hot. It feels like 100, but I'm sure it's at least 85. When you're above 85 in the daytime, you really don't have to worry too much about white mold. You think of the dry years, the hot years we've had in the past, you just don't see as much of it. Dry beans are really sensitive, but in general, white mold is less of an issue. How about another water disease? We had a scare here in 2011 with another disease, 2010 a little bit. Does anybody remember talking about anthracnose? Yeah, that was a dry bean problem here. It could have blown up into a huge mess because we don't have a lot of management tools for it. But the reason that it started in the first place is because there was infected seed that was planted and you had a really cool, really wet spring. And then the rain shut off maybe in June, early July. And that early rain, the infected seed, and those cool temperatures really pushed that disease, and we haven't seen it. So I'm not particularly worried about it this year. You know, you want to use clean seed every time you can, to prevent this, but when it's hot and dry, you just generally don't see that too much. What about the other disease? I've been running my mouth about another disease for about 4 years now since we had a race change, and we've seen it every year, but it's never caused any problems yet. Rust, right? So it used to be that all the dry beans were resistant to rust, and a few years ago we had a race change, and all the dry beans in our area now are susceptible to rust. And we haven't seen a lot of rust, but part of that is because of all the white mold fungicides that have gone on dry beans. They tend to prevent rust. But rust is a disease that doesn't need a lot of rain. It needs dew. So whenever we get warm and whenever we get dry, I start to think about dry bean rust. And so as the canopies start to close, as we move a little further in the growth stages, you probably want to start thinking about rust. And I have some rust to show you, because a lot of you haven't seen it for a while. It's sunflower rust, okay? So it's not dry beans. They're young sunflowers. We grew them in the greenhouse, but it looks exactly the same as dry bean rust. You can't tell these two apart just looking at them visually. Okay, so as these get passed around, this is what you might start to think about looking for. And what you're looking for is a brown pustule with these cinnamon-colored dusty spores on it. All right? There's not a lot that looks like it. Look at the pustules. They're raised. They're bumps. About the only thing you'll mistake it for, really, is probably dirt after a rainstorm. It'll be splashed up on the lower leaves. Okay, so this is what dry bean rust looks like. Obviously, it's what sunflower rust looks like, too. But there's another big difference if you're looking for rust from dry beans and, say, something like wheat. When you see wheat rust, it's generally kind of all over the place. You don't have to look real hard to find it. It's because it blows up from the south in huge air currents. It just covers fields. But driving rust is not that way. Driving rust overwinters in North Dakota. So if you do start to see driving rust, what you're usually going to see are small pockets of rust. So let's pretend this is drivings for a second. So it looks like a really good driving field, right? So if you start to see yellowish spots, it doesn't have to be a lot of yellow, but yellowish spots that show up a little bit later in the season, and we're not talking like root rot type yellow spots, just a little bit of yellow hue on it, or they just don't look quite good enough, take a look out there. Go look for rust. Don't look on the upper leaves, look on the lower leaves, because this rust is going to be moving up, and it'll be the end of the season before it gets to the upper leaves. You know, like I said, it doesn't need a lot of rain, but it does need dew. So if you have dewy mornings, we stay warm, start to think about rust. The good news about rust is we can manage this very well. We've got a lot of fungicides in the toolbox. We've got timing worked out. Basically, if you see pustules before pintos start to stripe, before that R7, a fungicide application may be beneficial. And it doesn't matter if you use a Trizol or a strobilurin, they all seem to work pretty well. Stay away from the chlorothalonil and the white mold products. They don't work quite as well. But the strobilurins, the Headline Quadris, the Trizols, the Proline, the tebuconazole generics, the generic folicares, they all work pretty well. Any questions about any of that? The question was above 85 and you don't have to worry about it. Right. So when your daytime temperatures get that warm, it's a really tough environment for white mold to cause infection. I would never close my eyes and just imagine it's not going to be there, because white mold's pretty tough. But when you're in the 60s and 70s and it's wet, it's a lot more likely to be found. Days like this, there's no infection period for white mold. There won't be. And if you have consecutive days like this, things dry up really fast. The canopy doesn't stay wet very long. There's really not much for an infection period.
Irrigated sunflowers, though.
Sunflowers, yeah. So, so in the scale of susceptibility, soybeans, you know, they can get a hit, but they're not that susceptible. Dry beans are pretty susceptible. Sunflowers are really susceptible. Warm temperatures like this, it's still less likely, but sunflowers, if you're going to see it in any crop, it's going to be sunflowers. And part of the reason is sunflowers can get infected in the stem and in the head as well, whereas so that period is so long. You don't need to go cool for very long and wet for very long to cause an infection period in sunflowers. Unfortunately, there's no fungicides we have for sunflowers. All right, Michael, I'll turn it over to you. Thank you.
Well, behind us, you'll see lots of stakes out in this field. For those of you who were at our tour last year, or our row crop tour, you'll know that this is an experiment that we're conducting to assess how to optimize the application of Contans. Contans is a biological control agent for controlling sclerotinia. Okay, what it does is it's a fungus that degrades the resting structures of sclerotinia, or the sclerotia of sclerotinia. And the only way that you can get sclerotinia is if those resting structures produce little mushrooms called apothecia that produce spores underneath your crop, okay? And so the idea behind this biological control agent is to degrade those resting structures. And unfortunately, there's been very little work done at the application rate that's going to be economical for most producers in North Dakota, which is 1 pound an acre, okay? Most of the testing has been done at 2 or 4 pounds an acre. This product does cost $20 a pound, so 1 pound an acre is probably what most people are going to be willing to pay. And so we're testing application rate, application timing in terms of fall versus spring, as well as application timing within each of those windows. So last year we tested springtime application timing. We tested we applied every week for I think 5 different weeks in the spring. This particular year we're testing fall application timing. So we tested a series of applications in the fall, a series of applications in the fall to see how late you could go and still get efficacy. Okay, last year's experiment, what we had shown is that when sclerotia are primarily on the surface, what we had for results was that the fall application was better than spring. No surprise there. Sipchem Advem, which markets the product, has said as much. And if you just think about how this works, it makes sense. You have a microbe you're applying on there. You apply it in the fall, and you have a little bit more time to run. Okay, it has a little more time for that microbe to degrade the sclerotia. Okay, but I know that it can be hard to get out there and apply in the fall. We have a lot going on in the fall. It can be difficult. We also showed some efficacy in the spring. But let me stress, those results were primarily with the sclerotia primarily on the soil surface, also some in the soil profile. We look forward here, as we go forward, all these plots out here are small plots separated by 60 feet. And what we look forward to doing, what my plan here is, after the second year of this experiment, we're going to switch to large plots. Okay, so starting next year, I want to put out half-acre plots, in which that whole half acre is treated in a given manner, okay? And a lot of this testing will be done with the sclerotia primarily within the soil profile, just like most of our conventional tillage producers would have the sclerotia. So this is a work in progress. It's been informative, at least from the first year. We thank the Soybean Council for funding this work. And I would stress that even though this work is being done on soybeans, the results will be directly applicable to the other crops. Okay, again, we're testing a biological control agent for the degradation of the resting structures of the fungus. If you degrade enough of those resting structures, you get less spore production, you get less disease. It doesn't really matter what your crop is. Okay, and so these results will be directly applicable to other crops as well. Sam said these are not ideal conditions for white mold, okay? They're great conditions if you want to avoid white mold in your crop, but what I have found is that last year as well was dry and hot here, and we had no problem establishing white mold in our trials. We just had to irrigate a little bit more aggressively. These disease management trials are such that you need to have the disease in order to generate informative results. But if you irrigate a little bit more aggressively than you might in a commercial production setting, you can still establish the disease and evaluate management strategies. And so I have pretty high confidence that we should be able to generate meaningful results again this year. And I look forward to, hopefully at the end of this season, having a good enough idea of what the optimal strategies for contans might be that we can then move into large plots and really test this on more of a scale that I think a lot of producers should hopefully find broadly relevant and informative for their operations. Okay, I believe Sam Markell has a few more words, and I'll let him go ahead and start here. After that, I'll give you a brief update on our pathology program, major research results for these broadly for our row crops.
So I mentioned a little bit about the dry bean diseases that we're looking at, kind of the big three, the anthracnose, the white mold, the rust. The same, those are specific to dry beans with the exception of white mold, but the same environmental conditions are true for sunflower rust. And yeah, even though I brought some from the greenhouse, I was able to find during one of the talks some sunflower rust on the station. So if you're growing sunflower rust, it's something you want to think about, just to keep an eye on that. We can manage that if it does get out of control. Just you want to make sure that you're on the ball, because if you get behind it, it's really difficult to deal with. So I was going to talk a little bit about soybeans, and there's a soybean rust, right? Everybody heard of that? Okay, forget about it. It's not a problem. Dry bean rust is specific to dry beans and it can cause problems. Soybean rust causes problems if you live in Louisiana. And we don't live in Louisiana even though it feels like it today. So I would just forget about soybean rust. But there is a disease in soybeans that I think we should be thinking about when it gets relatively hot and relatively dry. And that's soybean cyst nematode. So soybean cyst nematode is a microscopic worm. It's a lot different than everything else we deal with. But we've been able to confirm in 3 counties in North Dakota. So all the Red River Valley counties and then the southeastern corner. So the closest find we've got here is in Barnes County. But this is a disease that can cause a lot of problems, and it's moving, and it will continue to move. It's a little worm, it forms cysts, and so everything that moves soil moves it. We move it with equipment, wind moves it, water, flooding moves it, a lot of different things move it. And eventually it's going to get here. It could be here already, but we've certainly not confirmed it. So as you go through the season, and you're going through soybean, and you're growing your soybeans, one of the things you want to start looking for is if you start to see small yellow patches that maybe show up at the end of July, early August, soybean cyst could be causing that. Other things can cause it too. Root rots can cause that damage that you get really early. Plant gets water stressed, it finally starts to show up in August, or of late July. But soybean cyst is notorious for that. So if you start to see a little yellow patch in your soybeans, unrelated to water, get in there and take a look. And what you'll want to do is you'll want to go into the ground. You can't see any symptoms above ground except yellowing when the beans start to get stressed. So try to get in there and take a look at the roots. You can do this visually yourself with a shovel. Be very careful, get the whole root ball, and very carefully move the soil off the plants. And you could see cysts. The better way is to get a soil test around the time of harvest. It could be before or after harvest. Go into that area with a small probe, stick it around close to the roots. Remember, you're looking for the roots themselves, so don't put it between the row, put it right at the roots. Dab the roots, and then send it into a lab like AgBi's, NDSU, SDSU, and get it tested. It costs between $25 or $30. But if you do start to see little yellow patches show up, right around the 1st of August, you should start to think about soybean cyst. At least take a look. The good news with soybean cyst, even though it can be a devastating disease, we've got great management tools for it. We've let Iowa and Indiana take the hit for 10 or 20 years, and they've worked it all out for us. We've got resistance genes, we know how to rotate. The key is finding it early. Most of you will not see that, would be my guess. But over time, everybody probably will. Any questions? Greg asked about seed treatment as an option. So it's a little different than a lot of the pathogens we deal with. Most of the pathogens we put seed treatments on are for fungi, right? Molds, right? So this is caused by a worm. And up until the last couple of years, there haven't been any seed treatments that have been labeled for worms that have actually worked. There's 2 out there right now. There's one that Syngenta has and one that Bayer has that they've been marketing in the last couple of years. And we've had trials across North Dakota, but also across the whole north central states. And in some environments, they seem to make a difference, and in some environments, they don't. I'm not sure in this area that we're really here yet. I think we're still in like, okay, we got to figure out if we've actually got it before we start dealing with it. But that may be an option by the time we start to see problems in this region for it. Because those seed treatments will improve over time, would be my guess.
We'll talk about our broadleaf crop, row crop research briefly here. First off, talk about the crop that has mostly moved out of this area, but I know there are still some folks growing it, and you don't have to go that far west to find it. Sunflowers. Now, outside of birds, what's the number one reason why a lot of folks have stopped growing sunflowers? White mold. Got it. Okay, now white mold, as Sam had mentioned, can affect your stalk, and it can affect your head. Now, the sunflower breeding community has put tremendous effort into breeding for resistance. Now, there is no complete resistance to white mold on any of these crops, okay? But there are differences in susceptibility, and they have made tremendous strides in this regard towards developing sunflower hybrids that have reduced susceptibility. A lot of the screening work for the susceptibility has been coordinated here at Carrington. And since I have come here, I have made a really concerted effort to improve our methods, improve the replicability of our results. And I think we're getting to the point where we're really getting some really good, solid data. Last year, I was really quite happy with replicability of results across locations. We tested multiple locations, and we're continuing to doing inoculation work to refine our methods. Okay? But as it stands, we are getting to the point where we're getting really good, solid data. And I just want to let you know that if you are growing sunflowers and you're worried about sclerotinia, at least for head rot, which is what we screen here at the station, you can go to the Carrington Research Center website, look on the left side, you'll see a link for plant pathology. Okay, click on that, and then scroll down that page till you hit sunflowers. Okay, and there you'll see a link there for our screening results. And there are commercial hybrids there that have performed well, primarily oilseeds, but we do now have some experimental confections that have looked pretty good. Now, again, this is not 100% resistance by any means, but there are really dramatic differences in susceptibility between the most resistant to the most susceptible. So if you're interested in sunflowers, take a look at that. It should be a useful tool. I'd say out west this year, in parts out towards Minot, for instance, with all the rains this year, this would be a really relevant tool. On soybeans, we have a concerted effort to help screen new compounds for efficacy against Phytophthora root rot, Several of the companies have new compounds coming onto the market, and we have been leading a really concerted effort here to help screen those compounds and help bring them to market for you here. And I believe one of these compounds should be on the market already next year. The other one is probably a few more years away. We'll have more details next year after it's actually labeled, but the one that's coming onto the market next year at least has looked really good in our trials these last 2 years. The other major effort we have on soybeans is our ongoing Sclerotinia research. Beyond contans, we are also, which we talked about back at that pivot, we have looked at foliar fungicides. Up to this point, the only fungicide that has reliably provided good control of Sclerotinia on soybeans for us in our trials is Endura. Okay, and this last year we found that it worked actually quite well, even at the low rate. Okay, and so it's labeled from 5.5 to 11 ounces an acre, and even down at that low rate it performed quite well. So what we're doing this year is we're no longer testing all registered products. I think we've got a pretty good handle on how the various registered products perform. But what we're doing now is a row spacing trial. The Sclerotinia testing for fungicides has always been done on solid-seeded beans. Now, that's problematic on multiple levels. First of all, almost no one plants solid-seeded beans, especially if they're worried about white mold, okay? And second, your fungicide coverage is going to be reduced, okay? And so what we've done here is we've taken the best performing fungicides from our multiple years of tests. That includes a low rate and a medium rate of Endura, as well as a tank mix of Proline and Topsin. Okay, and we're also testing Approach, a new product from DuPont that has given some promising results. At this point in time, we need more data before I would offer any recommendation. But we're testing this on 7, 14, 21, and 28-inch rows. Okay, 6 replicates. Hopefully that should give us some really nice data on how fungicides perform for control of this disease under those different row spacings, and what you might want to optimize if you're in a spot where you're worrying about that disease. The climate we have in this area this year, we're not worried about white mold. But we'll have another cool wet year, and that year we'll have the data ready for you, and hopefully that'll help guide your management decisions. Dry beans. We have made a rather concerted effort here to test relative efficacy of registered fungicides for control of white mold on dry beans. This last year, we ran trials in Fargo, Langdon, and here. Okay, this year we changed track, and what we're testing are narrow and wide rows in Staples, Minnesota, and here. Okay, and actually my crew, my research specialists and I drove out to Staples to plant that trial because they didn't have the capabilities there to plant the desired row space. Outside of that, though, the Staples crew is managing that trial on their own. We'll help them with disease ratings, but they're doing that on their own. And then we're running the trial here as well. But up till now, just so you know for reference, over the trials we've conducted over the years, Endura has consistently performed well. Okay? And I would tell you that from what I have seen with Topsin is that there's a rate response. At 20 fluid ounces, which is equivalent to 1 pound, it doesn't work very well. You move up to 30 fluid ounces, which is equivalent to 1.5 pounds of the dry formulation, and it starts working pretty well. And it is labeled up to 40 fluid ounces as a single app, okay? And that obviously works quite well too, but there is a rate response here, okay? And typically Topsin provides some pretty good results. I'd say that in our test to date, it has not performed quite as well as Endura, but you need to weigh costs versus the cost of the product versus efficacy. And in many environments where the Sclerotinia pressure is moderate, you may find that the Topsin gives you satisfactory results. I would stress, though, that we are continuing our testing. I haven't done as many years of testing as I'd like to formulate really solid recommendations, and that's why we're continuing this effort. And you may find you will find more detailed recommendations as we go forward. I would encourage you to come back for the row crop tour. The row crop tour, you'll be able to see a lot of these things visually. I guess there's one experiment in the soybeans that I forgot to mention. I think this is a particularly exciting one. Right behind you here, you'll see soybeans planted at various row spacings. And what we are doing here is, gosh, let's step back a minute. When you buy your soybeans, you typically see disease ratings for various diseases. You mentioned some of the diseases that are usually rated in terms of susceptibility. Phytophthora, great. Ever seen a white mold rating? Typically there are white mold ratings. Okay? So soybeans differ in their susceptibility to white mold just like sunflowers do. Typically these differences are driven by plant architecture, so how well that plant lets in airflow. What we are testing here is we've paired soybean varieties from the same breeder that are very similar maturity, but for which that breeder has assigned different levels of susceptibility to white mold. Okay? And we're looking at the performance of the moderately resistant versus highly susceptible varieties under these different row spacings, so 7, 14, 21, and 28 inches. And looking at how you can optimize your use of partial resistance relative to row spacing, and whether your partial resistance is up to snuff out here. Okay? Breeding efforts for partial resistance to white mold in this area with our maturity groups of soybeans is in its infancy. And so we don't really know how good it is. We know that in maturity group 2, they've done some pretty good work there. But here it's still in its infancy, and so we'll generate some data for you on that.